Hello viewers on YouTube. In this video tutorial, we are going to consider Pascal's triangle. So now, in algebra, whenever you want to expand a binomial, take for instance, you want to expand something like a plus b to the power of 2. This is straightforward, as you can just duplicate the binomial twice or just once, a plus b, and then do the normal expansion process. But notice that as this value gets more higher, then the process of expanding that binomial becomes much more tricky and much more complicated. Take for instance, raised to the power of 7. To expand this might be a little bit difficult, as we need to be duplicating the binomial continuously until we have it 7 times. Are we together? Now, to save the stress, to save this kind of excess work, then that is when Pascal's triangle comes in. Though there are some other theorem or techniques we can use to get our answers in no time, but part of them is Pascal's triangle. At least it's way more better than this algebraic process. Perfect. So basically what Pascal's triangle does in essence is that it quickly helps us to find the coefficients in binomial expansion. Are we together? So how does it work? Here's how it works. So for a binomial expansion, a plus b with degree 0, the coefficient will be 1. And for binomial expansion, a plus b with degree 1, the coefficient will be 1, 1. And for binomial expansion with degree 2, its coefficient will be 1, 2, 1. And for binomial expansion plus b with degree 3, its coefficient will be 1, 3, 3, 1. Alright? Very soon I will show you how I'm getting these values. And for binomial expansion, a plus b with degree 4, its coefficient is 1, 4, 6, 4, 1. And this pattern will continue. Now you notice that the kind of pattern being generated by this seems very, very close to a triangle shape. So that's why this technique is often referred to as Pascal's triangle. The Pascal there is the name of the French mathematician that developed this idea. Perfect. Now, the goal is, how do you get these numbers? What you need to keep in mind is that for any binomial expansion, the coefficient will start from 1 and it will end at 1. Alright. Now, also, what you need to keep in mind is that a binomial expansion is to the power of 0, the result is 1. From your knowledge in algebra, you already know what that is, right? Perfect. Now, when it's raised to the power of 1, it gives us 1, 1, The expansion will just be the first term and the second term. So this third one is where work starts from. So now, when you write the first one that started and the second one that ended, what will be at the middle will be the sum of the two ones above it. So that's how we got 2. Now for the power of 3, we go to the one that started, the one that ended. The next thing is to add these two numbers. 1 plus 2 gives us 3. Again, 2 plus 1 gives us 3. And we're good to go. Now for the raised to the power of 4, we write 1, we write 1. Alright, so we add these two numbers. That gives us 4. Again, 3 plus 3 gives us 6. Again, 3 plus 1 gives us 4. And we have the last one. And that's how you are going to be generating these values for the coefficients. Now, feel free to find the Pascal values for a binomial expansion with power 5. So we start from 1, it ends at 1. So we have 1 plus 4, 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is the 5, and that's it. Now what about this to the power of 6? To the power of 6 start from 1, end at 1. So 1 plus 5 is 6, 5 plus 6 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6. And this is simply the best and easy way to generate your Pascal values. Now here's what you need to know. This Pascal triangle or the Pascal techniques has limitation to binomial expansions. Okay? And part of the limitation is that, which is the most important part, is that you can only use it when the exponent of that expansion or of the expression is a positive integer. Alright, when these values are positive, when they are negative, we can use Pascal. When they are rational number, we can use Pascal. But instead, another techniques. But not in this video. This video is just to focus on a power with positive integers. Perfect. Now that we know how to generate the values, let's try to understand how to make good use of them. Example number 1. So consider the expansion 2 plus x to the power of 5. So let's say we have to find, or we are asked to expand this binomial. And sometimes we just said find the first 3 terms of this expansion. So it means after you expand it, you don't even need to expand it entirely. You understand? Just find the first 3 terms. Another thing you need to know is that for any binomial expansion, the number of terms will be n plus 1, where n will be the power or the exponent. The number of terms that each binomial will have will be n plus 1, where n will be the exponent. What am I saying next sense? This kind of expansion now, it means it's going to have 6 terms, n plus 1, 5 plus 1 term, that's 6 terms. You understand? They will be having 1 above the exponent. So if you're expanding any binomial and you observe that at the end of the day, all the terms you are having is not 1 beyond the exponent, then it means your expansion is not yet completed. Perfect. So it means we'll be having 6 terms for this expansion. But first, let's write the Pascal values for 5 exponents. Alright. So we listed it earlier. We said for 5 exponents, its Pascal triangle is simply 1, 5, 10, 10, 5, 1. Now you count this number, you realize that it's going to be 6 in number. Alright, going to be 6 in number, which is 1 above the exponent. Now these are all the coefficients of this expansion. So now to find the expansion in next sense, you will now be taking each of these values one after the other. So let's start with 1, then you multiply it with the first term you are seeing here, that's 2, then multiply with this one as well, times 3. So I said times 3 times x. Perfect. Now that will be the end. Alright. The next thing is that you will now take the exponent you are seeing right here, you assign it to the first term, which is 2, in this case 2 raised to the power 5. Now for this other one, its exponent will be 0. So the logic will be such that this one will be decreasing by 1 and this one will be increasing by 1 as we are moving forward. Okay, in terms of the coefficient we are selecting. Now each of these values will be associated with positive sign. So the next one will be plus. So taking 5 now, we have 5 times the first one 2 times the second one x. And that's not all. You take the exponent again, but instead this has occurred already. So decrease by 1, that's 4. Now increase this one by 1, that's 1. Perfect. Alright, again plus. The next one is 10 times 2 times x. This becomes 3, this becomes 2, plus another 10 times 2 times x. This becomes 2, this becomes 3. Again plus 5 times 2 times x. So this becomes 1, this becomes 4, again plus 1 times 2 times x. Now this becomes 0 and this becomes 5. Perfect. As you can clearly see, it ends with the exponents. So that shows that you're on a good side. Now let's do the number math. 2 raised to the power of 5 is 32. 32 times 1 is 32. And x raised to the power of 0 is 1. This entirely, the product of these values is 32. So we have 32 plus, now 2 raised to the power of 4 is 16. And we multiply 16 by 5, we are going to have 80. Now x raised to the power of 9 is 6, so we have 80x. Perfect. Plus, now 2 raised to the power of 3 is 8, we multiply by 10, we still have 80, and now we have x squared, plus another 80x squared. Again, 2 raised to the power of 2 is 4, times 10 is 40, and we now have x raised to the power of 3. When we do that product, we have 40x to the power of 3, and almost to the end. 2 raised to the power of 1 is 2, times 5 is 10, times x raised to the power of 4. And finally, we have 2 raised to the power of 0 to be 1, times 1 is still 1, multiplied by x raised to the power of 5. And this is the expansion of this binomial. As you can clearly see, this saves time compared to we expanding it or duplicating this expression 5 times just to have the expansion. Are we together? Perfect. So that's how to easily and mentally expand binomials with positive index. Example number 2. So feel free to pause the video and figure this out yourself as well. Now consider the expansion 1 over 2x minus 3 all the way to the power of 4. Feel free to pause the video and figure this out yourself. So sometimes the question won't even just ask you to expand the entire. I think I've said this earlier here, because they just said find the first 5 times, the first 3 times, you understand? So you don't need to expand everything, but if you want, you can expand everything and take the terms they say you should find. Now another way the question can come is that they might say find the coefficient of x raised to the power of 3. What does this mean? It means you will expand this thing. After you expand it, you will now locate or identify the variable raised to the power of 3. Now once you can identify that, take the coefficient. That will be your answer. In this case, for this problem, let's also find the coefficient of x raised to the power of 3. But at the same time, let's expand the binomial. So to expand this binomial, we need the Pascal values for index of 4. So what is the Pascal value of index of 4? If you go back to your Pascal generator, you have 1, 4, 6, 4, 1. This will be the values. As you can see, there are 5 in numbers, which shows that we're on the safer side. Now, let me get rid of this one. Well, I don't need to get rid of it. Let's consider that way so that I can use that as a reference. We want to find the coefficient of x to the power of 3. So just like before, we start with the first one. 1 times. So you take this first value, 1 over 2x, put it in a bracket. You can see it's not a single term. It's a single term, but it has something attached to it. Then again multiply by, now this is negative 3. You can see that negative belongs to 3. So again minus 3. So now this is raised to the power of 4. It started from 4. It started from 0. Then plus 4 times, again 1 over 2x. So this decreases to 3. Again multiply by negative 3 raised to the power of 9. And continuously we have 6 times, again 1 over 2x. Then raised to the power of, it decreases to 2. Again multiply by negative 3 raised to the power of 2. That makes sense. Again plus 4 times half x raised to the power of 1. Again multiply by negative 3, raised to the power of 3. And finally plus 1 times half x raised to the power of 0. Then again multiply by negative 3 raised to the power of 4. Perfect. Next thing is just to do our normal operation. Now please, while doing this product, be very careful how the student makes a lot of mistake in this process. Make sure you are very careful. Even in fact, I suggest you find all these values first, one after the other. After that, you can now multiply everything entirely. But to keep the video short, we are going to be doing everything straightforward. Alright. Now, half x goes to the power of 4. The 4 will be distributed to x and 4. So this becomes 1 over 16. And this is 0. When multiply with 1, we still have 1 over 16 goes to the power of 4. So that's the value for the first time. Alright. Now, plus. Now, take in mind, negative 3 is by 0 is still 1. The 0 will not show up in this case because everything has become 1 entirely. Plus. Okay, I've written the plus already. Oops. Now, 1 over 2x is power 3 is 1 over 8. 2 to the power of 3 is 8. So that's 1 over 8x to the power of 3. Now, negative 3 is power 1 is negative 3. And multiply it by 4 gives us negative 12. Well, I think, let me write this out so that you can get the simplification. So now we have 4 times 1 over 8x to the power of 3 times negative 3. Now 4 can reduce this to 2. Then we can just add negative x to the power of 3. 3 will be there, divided by 2. So this is the simplification of this second term. So that's negative 3x to the power of 3 divided by 2. So therefore we have, instead of this to be addition, but let me write it first. So later on we can take the effect. So that's negative 3x to the power of 3 divided by 2. So that's for the second term. Now for the third term, 2 goes to the power of 2 is 4. So that's 6 times 1/4. 6 times 1/4 of x to the power of 2. It's affected both of them. Now negative 3 all squared is simply 9 times 9. Now 2 reduces this. We have 3, we have 2. 3 times 9 is 27. So this gives us 27x squared over 2. Perfect. So we have plus 27x squared over 2. Now the negative has gone. Keep in mind, we have squared that. Perfect. Now for the second to the last time, that's 4 times. Now this is just raised to the power of 1. It means we have it back the way it is. Times half x. Alright, then multiply by negative 3 to the power of 3 is simply 27. But instead, negative 27. Because negative raised to the power of 3 is negative. Now 2 reduces this to 2. And we have 2 times 27. Now multiply 2 with 27. That gives us 54. 54 times x, negative 54x. So that will be negative 54x. Perfect. So that's for the fourth term of, yes, for the first term. So that's negative 54x. And finally, this one. So this is goes to the power of 0. It has gone. Negative 3 raised to the power of 4 is simply positive 81. And this is expansion of this binomial. Now, these can affect themselves. Then we have our final answer to be simplified to 1 over 16x to the power of 4 minus 3x cubed divided by 2 plus 27x squared divided by 2 entirely minus 54x plus 81. So now we have provided the solution to the first question, which is the expansion of the binomial. Now to the second question, which is the coefficient of x to the power of 3, our answer will just be locating x to the power of 3. This is it. So its coefficient will be negative 3 over 2. So final answer is negative 3 over 2. That's how to provide the solution to that kind of problem. And that's how to easily make use of Pascal's triangle effectively in expanding binomials with positive index. I hope you find this helpful and understandable. Now you can expand binomials with positive index. Thank you. See you in the next video. So this is your exercise. Feel free to share your solution via the comment section below. Consider finding the expansion of 3 second minus 2/5x, then all those to the power of 7. At the same time, you can consider the expansion as well. So feel free to find the coefficient of x squared in this expansion, 3x and plus 1 over 2 raised to the power of 8. So you find the coefficient of x raised to the power of 5 for me in this one, and you find the coefficient of x raised to the power of 7 for me in this one. However, you have to expand both of them in these cases. Thank you. Bye for now.